Hi everyone, we are discussing about the backpropagation technique. Why backpropagation technique is used is to reduce the loss or the error. In backpropagation, the difference between the actual output and the expected outcome is measured. That information is given back to the input layer and some adjustments we make in the weights so that the error reduces. In this diagram we can see again there is an input layer, hidden layer and the output layer. So we find the error and we give that error to the hidden layer weights. So the gradient of error is calculated with respect to each weight. The gradient of error, or gradient means the rate of change of the error, is calculated with respect to each weight, and that is given back to the hidden layer, and based on that weights are readjusted so that the error in the output is minimal. So that is what is actually done in the backpropagation. Now we will come to the concept of gradient descent. Now weights are adjusted, right, to reduce the error. For adjusting the weight, we use the concept called as gradient descent. Gradient descent is an optimization algorithm that is used to find the weights that will minimize the cost function. We saw that bell curve, if you could remember, that bell curve should be such a way that its bottom point, right, it is having a bottom point. If it is having a top peak point, then cost function is more. So we want a less cost function. So minimizing cost function means getting the minimum point of the cost function. In that bell curve, we want to identify the minimum point of the cost function. So gradient descent aims to find a weight corresponding to the cost function minimum point. Now we want to find that minimum point. So in that bell curve, or in that curve of the cost function, that is curve in the weights with and the loss, right, it's a three-dimensional curve. In this diagram you can see a three-dimensional curve. It is there. We are going to navigate through this curve to find out the point where the cost function is minimum. So there is a starting point. We keep on going till we find the point where the cost function is minimum. So as mentioned here, we want to get to that point which is at the bottom of the curve. Likewise, the navigation has to be done. For that, the gradient descent is actually used. So finding the direction using the gradient. There are two types of gradient. So we have to navigate. So we can consider the curve of that loss versus weight like a mountain, right? So we need to find the minimum point in that mountain, right, where we are going to reside or going to be safe. For that we need to navigate on the mountain, right? We need to go up and then we need to come down to find that low elevated point, right, where we have to reside near to that mountain. Likewise here we need to climb the curve, come down. So for climbing the curve we use a positive gradient as shown in the figure. For coming down to the curve to find the minimum point of the cost function, we use the negative gradient. So there are the positive gradient and the negative gradient. Now the step size and the learning rate. The step size for navigating the cost function is determined by the learning rate. The learning rate is a tuning parameter that determines the step size at each iteration of the gradient descent. It determines the speed at which we move down the slope. Alpha is termed as the learning rate. we could have heard about learning rate in the perceptron, right? The step size plays an important part in ensuring a balance between optimization time and accuracy. You can see in this graph versus graph of loss versus weight, right? Here we are finding the lowest point, right, which is having the minimum cost function. So what is the speed at which the network finds this lowest point? That speed is called as the learning rate. So we will discuss further about this. Thank you.